Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 7th. Looking at significant wave heights for the South Pacific Ocean, we see not a whole lot going on. Whatever seas there are either aimed hard to the east, out of the California and Hawaii swell window, or hard south towards Antarctica, and virtually nothing going on under New Zealand, at least for now. We'll start this week's forecast, as always, looking at jet stream level winds. Jet stream level winds, up about 30,000 feet, help support the formation of storms, and when those storms do form, help direct their track. Currently, we have a very split jet stream flow. No troughs of interest in the greater South Pacific. This does not support storm formation. What we're looking for is a trough, a bow in the southern branch of the jet, pushing to the north. That would set up a clockwise circulation that is effectively low pressure in the upper level of the atmosphere and also manifests itself down in lower levels of the atmosphere, and that of course generates wind, and wind generates swell, and swell radiates towards your break and creates surf. We see nothing that supports that, at least at the moment. A little bit of a trough here trying to organize under Tasmania, but not of any real particular interest. As we move forward, we continue seeing this ridging split flow, but notice come Tuesday a bit of a trough here starting to develop. Notice it's a little bit cut off here, but at least winds pushing to the north in the Tasman Sea, getting a decent amount of velocity there, 140 knots pushing north, maybe good for the Fiji area for a second, but then it quickly flattens out, cuts off, and it too dies. Back to the zonal split flow, that is the northern branch running flat west to east, the southern branch running flat west to east, or more or less, though a little bit of a trough starting to show up here on Thursday. We roll this out, and that trough gets a little better defined into Friday. What is that? 100, 110 knot winds pushing to the north, maybe supportive of a little bit of low pressure, and even gets better defined in terms of the area, but less wind flowing up into it into Saturday night and Sunday. Still, that's better than the big ridge that's covering the southeast Pacific. Maybe some low pressure, if not a gale, could form here in the southeast of New Zealand area by Sunday, or even beyond that. It holds pretty good, so there's some promise here. Let's go take a look down at the surface. Next up, surface level winds, surface level pressure. Notice high pressure here, weak low pressure here, producing north winds pushing south. We saw this on the significant wave height chart. East winds here, pushing east out of the picture. No fetch pushing to the north. And then some fetch in this area under New Zealand, but notice the wind vectors here all pushing to the southeast. So for now, not a whole lot going on. Let's put this into motion, see what happens here. A nice little gale forecast, actually a storm, 55 knot winds, just little shades of it there. Monday, midday, aimed reasonably well up towards Fiji. Maybe it would get some traction. Maybe it will generate some swell pushing up in this area. Not guaranteed. And then watch the core of the storm. It's still pretty decent. 50 knot winds here, running more or less flat to east, though a definite sort of southeast push there on the eastern side of that fetch. And that continues. The core of the storm is falling southeast. You really want the core of the storm pushing northeast up towards all our major forecast targets. Anyway, that system continues. Most of the fetch aimed towards Antarctica into the Ross Ice Shelf and kind of just peters out. And then we see another gale trying to push under New Zealand on Thursday. Earlier versions of the model had this system very strong. It's not looking nearly as optimistic per the 18Z run here, but certainly an area to watch because we know a trough is forming in this area. Anyway, 35 knot winds forecast, aimed well to the northeast, and even a little bit 45 knot winds there, 50 knot winds, maybe more, but just over a tiny area. Let's see how long they last. Not horrible, and actually lifting to the northeast. So, and we're into Friday, almost Saturday now, with more low pressure building in this area. We know there's a significant trough here. Lots of fetch, not strong necessarily, just little pockets of wind. Most of it's in the 30, 35 knot range. That's only good for like 13-second period swell. That would not make the journey up to California and barely to Hawaii. Maybe good though for Tahiti. Anyway, we'll watch this. It continues to churn in that area. Good upper level support, something to look at. Let's go take a look at the significant wave height charts now. All right, first up, significant wave height charts here. We're actually going back a full week, and the reason we are is because there is a gale that developed in this area here, and we're specifically going to bring up the Southern California Great Circle charts. Ignore this. This was Andres. It is gone, of no concern anymore. But let's watch this area and see what happens. And we see 26-foot seas on Sunday night a week ago. An additional seas, 28 feet on about the, what is that, the 187-degree track. And notice this, they're not really pushing to the north into Southern California, sort of a 45-degree angle, but they are pretty well to the north. And then up to 30-foot seas on about the 183 or 4-degree track into Southern California. This was, as of Tuesday, almost a week ago, and then that system fades out. Swell is in the water from that, expected to push into Southern California by now into Monday and Tuesday and Wednesday. And for that matter, some of this energy is also supposed to reach up into Northern California as well, and we can see that on the charts here. There is the 179-degree track. We'll actually go back, and as you can see here is about the 180-degree track or so. Maybe more back in there, the 185 or so. Anyway, so swell is in the water as well for Northern California. And now here we are, current, what was Hurricane Bianca working its way into the Baja area. Really not ever in the Southern California swell window, except maybe out towards Point Conception, but not a whole lot expected from Bianca, though winds were good, up to 115 knots. What is that, nearly 135 miles an hour. So good solid storm, second in this area in a very short period of time. That certainly is a testament to the amount of warm water in this area, presumably from a building El Nino or from warm water that's been there since last year around this time. Anyway, put this into motion. Here we go. We saw a gale developing. Here's the one that we were saying would perhaps make some swell for Fiji. But notice most of the fetch here is all aimed to the east, kind of bypassing the Tasman Sea. And so then we say, okay, our next shot is let's take a look at California. And notice here's the path that the swell has to be traveling up, and it's doing at least 45, almost looks like 60 degrees east of those angles. Probably not much swell pushing up to the north. And for that matter, if you want to look at Hawaii, it's even steeper relative to that. A full 90 degrees, totally perpendicular. Very low odds for anything other than maybe tiny swell. Anyway, that system moves out and dies, and now we're into Thursday. Then here's the broader gale that we were looking at. Seas in the 30-foot range, and it just doesn't quite get it together. It tries, but just little bits of energy fragmented in this area. It looked much better this morning on the 12Z run, but the 18Z run has kind of fallen apart. Still, certainly worthy of watching this area in the days to come. When we roll this out, and we're at 180 hours, bits of energy floating around here. We know there's a trough in this area, generally supportive of gale development, so it's still almost a week out. Let's see what happens, give it a couple of days. But for now, things seem to have taken a back seat in the South Pacific. Not a whole lot of swell production. We've had a great run for the better part of a month now of just continuous southwest swells into California. Bits of good energy. Last swell was very solid in Hawaii, and as well as Tahiti and other locations, certainly all Central America and down into South America. But now things are taking a back seat. And just for fun, we'll take a quick look at the Northern Hemisphere. This time of year, one would expect nothing at all, though there actually is a gale here. Not even a gale, I'll say a fetch. It's barely, 17-foot seas or so forecast, maybe pushing 18 feet. The model says 20 feet. I'd say that's on one grid square, maybe, certainly nothing. Oh, and there we go. Actually clicks over to 20 foot on Monday night. So maybe some 13-second period swell could result in this area, and maybe even energy radiating down into Hawaii. Certainly there was a surprise little northwest swell there for the islands on, what day was that? Saturday. Some good sized surf into the North Shore for the time of year. Certainly rideable. And we'll see whether this materializes or not. It's too early to start making any conclusion about whether this is El Nino related, because what's really happening here is we got to fade out. We got to get the winter season and the spring season to fade out. So it's not till after about July 15th that you start looking here and making any proclamations about what impact warming in the eastern equatorial Pacific would have on the jet stream, et cetera, et cetera. But at least the flow looks reasonably decent for this time of year. Nothing outrageous. Also notice here, wind swell generated fetch. That is high pressure out here, creating a gradient off Cape Mendocino, generating seas in the 17-foot range. Actually, when does that start? Oh, actually, some of the models we saw said Wednesday, but getting solid 30-knot winds forecast in this area, just a tiny area, but that generates good wind swell, and supposedly was south winds eddy flow in effect, so Central California and even parts of Northern California could see some surf from that, and that holds into Saturday, and then Sunday, and then it starts fading out, and we're at 180 hours out, and that's it. So really, this time of year, all you're looking for is wind swell anyway. But we'll keep watching, see whether that gale that we saw earlier develops and pushes south of the Aleutians. Let's go take a look at the long-term indicators now. First up, the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. You want to see negative numbers here. Negative numbers suggest the active phase of the MJO. The active phase of the MJO helps support the formation of El Nino. Certainly helps beef up the jet stream in winter months in the northern hemisphere and helps promote storm formation. Right now, you can see we don't have much negative numbers. These are the daily numbers, pretty much suggestive of the inactive phase of the MJO, though the 30-day running average is negative and still reasonably negative. We had a long run of the active phase of the MJO. Now it's time to pay the piper. If in fact El Nino were developing and getting a good grasp on things, you would expect to see negative numbers here, and with the 90-day average too. And you'd expect to see the 90-day average down in about the -15 range. We're not there yet, but overall, things are not horrible. We've had a good run of the active phase of the MJO, westerly wind bursts, Kelvin wave development, all the things you want to see. We're taking a little bit of a breather right now. And here's another way to look at the 30-day Southern Oscillation Index. And here we are current. You can see that the 30-day average has been rising, but we were on a tear there with a good long run of negative numbers. And we've been down low since at least July of last year, and actually the big change turned over in about February of 2014. This is when we thought that maybe the Pacific decadal oscillation switched from the down phase to the up phase, or more supportive of El Nino, and so far we've seen nothing to indicate that that is not the case. We had a bit of a hiccup here, but then we've been negative for, a year now, and the general trend is downward. So we'll see what happens shortly. Next, we're looking at surface level wind anomalies. So this is actually the 850 millibar level, up about 4,500 feet above the surface. What we're looking for is westerly anomalies like that, where differences in wind speed and wind direction for this time of year. Typical winds in this area are from east to west, trade winds right along the equator, just a couple of degrees either side of the equator. And what we're really looking at is the area from about here, from about 135 east to about 170 west. This is what we call the Kelvin wave generation area. If you have westerly anomalies in this area, this helps push warm water that's normally pooled up in this area to depth, creates a thing called a Kelvin wave, which is a pocket of warm water, and that migrates from west to east, erupts over the Galapagos Islands, and is the hallmark of El Nino if you get multiples of them behind each other. Currently, we have the first time in a year easterly anomalies over a small area here in the far western Pacific, just barely in the Kelvin wave generation area. And this up at the surface, up at 4,500 feet. We also have weak westerly anomalies here right along the equator. This is current. And then as we move to the east, we see here we go. Here's Hawaii. Still very, very weak westerly anomalies. And then strong westerly anomalies are stronger here near the Galapagos. All this suggests to us is that the active phase of the MJO is moving out of the area. The inactive phase is moving in. The question is, how much easterly anomalies are going to be produced and how long are they going to last? The good news is, probably not too long. We're looking a week out. We see dead neutral situation here. No easterly anomalies. Here's Australia, so we're in the far west Pacific, going across the date line here. And then we get into the East Pacific, and no easterly anomalies at all forecast. Now again, this is up at 4,500 feet. We need to go see what's going on down at the surface. And here we go. This is the TAO buoy array, actual buoys on the ocean surface, giving us hard views of what's going on there. Here's the actual winds, certainly trades as would expect, but it's the anomalies that we're interested in. Clearly, and this is as of June 6th, so it lags a day behind what's actually going on. But we see clearly westerly anomalies from 160 east, let's say, to about 170. This is the Kelvin wave generation area basically is right in here. And we see westerly anomalies continuing. The other thing we noticed, we went and looked at the GFS charts. They are actually showing some east trades in this area way over here, but that all is supposed to die out within 24 to 36 hours. That is a good sign. And then dead, and I mean dead, neutral winds take over the Kelvin wave generation area, which is effectively we would expect to be back to westerly anomalies by, let's say, Tuesday or Wednesday of this week. If that were the case, that would be a very good sign. So we're going to know here in a couple of days how much legs this El Nino has. All right, let's continue on our tour. Here's another way to look at this. This would be the far west, but this is the whole globe all on one chart. Back in time, May 8th, this would be the far west Pacific here. This would be the far east Pacific roughly over here. These reds are westerly anomalies, major westerly wind burst in the early part of May. And then you can see these westerly winds slowly working their way off to the east. Classic, the MJO working its way across the Pacific. And then here we are current time. These blues are what one would consider to be easterly anomalies, though clearly there are no easterly anomalies. There's a little patch over here, but not much, not really bothering the Kelvin wave generation area. And per this, in another worst case 2 days, they're gone. And notice here, very, very weak westerly anomalies forecast, 5 days out, 7 days out or so. So we think we're through the worst of this current inactive phase of the MJO. If that were true, that would be a good sign. And here's another way to look at. This is outgoing long-wave radiation, ocean or sunlight reflectivity off the ocean surface. Oranges and reds suggest high pressure, the inactive phase of the MJO, much reflectivity off the ocean surface, and suggestive, clearly, the inactive phase of the MJO is in effect, per the statistic model, and they have it basically dying out about, let's say, 12 days, about a week and a half out, it's gone. The active phase building in the Indian Ocean, starting to seep its way into the West Pacific, per the statistic model. The dynamic model is not so encouraging. It suggests the inactive phase is supposed to hang around. But you know what? We don't care so much about the cloud patterns and reflectivity. It's actual, what are the winds doing on the on the equator near the dateline region. And per the GFS model, we're going with that for now. It's supposed to be dead calm winds by the time you get 3 days out. But this is showing the inactive phase hanging around for the next 2 weeks. The upper level model, same sort of deal. This is areas that are not supportive, the reds and yellows, not supportive of precipitation, the inactive phase of the MJO, and it shows the inactive phase working its way across the equatorial Pacific through about the end of June, the 27th. But the inactive phase, the active phase developing in the West Pacific, about the 17th to, let's say, the 20th of June, and then it takes over from then until, probably, about middle of July, and then the inactive phase again starts building out here, not making it to the West Pacific by the middle of July. Of course, who's going to believe a model 40 days out, but it gives you some indications. Now, one point to consider is if El Nino were developing, basically the MJO is supposed to disappear, and you wouldn't see either the inactive, or you'd see active, but it's just very weak like this. So we're kind of suspicious regarding what appears to be a strong inactive phase. We're going to watch and see what happens at the surface. If at the surface, we get no easterly anomalies or very weak ones and they'll last for a couple days, that suggests that this model is overstating the strength of the inactive phase. And it tends to do that, and we saw it last year when El Nino was trying to kick off. Next up, surface level temperature anomalies. Ocean surface temperature anomalies. Differences in normal for this time of year for all these locations. The hallmark of El Nino is warm water building up in this area right here. The core of it is right here. That is, during a El Nino development, you'd want to see a lot of warm water building up here. This is the result of, remember we talked about westerly anomalies here. They blow, they create Kelvin waves, warm pockets of water that move under the equator, erupt along the Galapagos and Ecuador coast, start warming the surface water here, and then trades pick that up and blow it back into this area. This is the Nino 1.2 area, they call it. It is the Nino 3.4, which goes from about 170 to 120, right in here. If you see warm water here and it stays warm, that suggests that El Nino's in play, and that warm water helps affect the jet stream and helps support storm development in the fall and winter months in the North Pacific. So that's why we're all interested in El Nino. Clearly, an El Nino signature is in play here. This is nowhere near La Nina. La Nina would be cold water, like that kind of cold water, but happening here, we see no sign of it. We see lots of warm water. No wonder tropical systems are gurgling up here. We expect to see more of that as we work our way into July and August. So right now, obvious signs, certainly looks like El Nino. All the major agencies are saying El Nino is in development. The question is, how big is it going to get? Are there going to be more westerly wind bursts? Are there going to be more Kelvin waves? And is this going to heat up? This area going to heat up more? We don't know yet, but we have our suspicions. Here's the current high-res anomaly chart. Here's the Galapagos. Notice warm water here in the, probably the 4+ degree range in this area. This from a Kelvin wave that impacted this area several weeks ago. In fact, we'll show you the peak of the warm water warming in this area, the peak of the Kelvin wave. So here it was at its peak. Notice this, so we'll just go back and forth. You can see where we're at. This was as of May 23rd. This is when the Kelvin wave peaked out. Here's where we are now. Notice things have settled down quite a bit, but still not horribly bad. Notice all the warm water here and all the way down in here. That has receded a fair amount, but do not despair. And yet one more view. Here's the Galapagos Islands. Here's the peak warming right in this area here. And we can actually zoom in. There's a virtual station here, and we can get some data from that. So here's a whole bunch of data. These are the anomalies at that station. You can see 3-degree anomalies in April. Coming up, here was the peak. Where was it? We get our way into May, and here it was right here, May 23rd, 4.58. Now this is one little tiny area in the ocean we're looking at. Temperatures peaked out. They settled down rather quickly, back down to 4.1. But now we went back up to 4.5, 4.6 or so in the June time frame. But based on the previous charts we saw, the extent of those warm waters is nowhere near, currently is nowhere near what it was back in this time frame. Still very warm, very much above normal, all good signs of developing El Nino. Again, back to the TAO data chart, anomaly chart. on the equator, 1.5 degrees anomalies all here. The Nino 3.4 area goes from here, a couple of degrees either side of the equator, to here. Clearly, much warm water here. The other thing to notice is westerly anomalies still in play. Barely, if that's an easterly anomaly, it's nothing. It's almost, just an anomaly in and of itself. So basically, the pattern looks very good on the equator. What is the source of all this warm water? Well, here is a view, West Pacific, East Pacific, at depth, right along the equator. Here's actual water temperatures, but it's not the actual water temperatures we're interested in. It's the differences from normal from this time of year. And here is another very interesting chart. A couple of days ago, a lot of warm water was shown pushing into the Galapagos area. The Galapagos would be here, West Pacific over here. But what we've now seen, at least per this, and again, this is TAO data. Notice these little X's. Those are sensors on the buoy anchors the whole way across the Pacific on the equator, that the Kelvin wave, or actually a second Kelvin wave, has formed. There was the big westerly wind burst in January, February, March or so. That created a first Kelvin wave. That created the initial pulse of warming that erupted over the Galapagos, peaking a week or two ago. A second pulse of westerly anomalies in the early May time frame pushed more warm water, and you can see this. You can actually see right here the shading. Warm water falling to depth, and where is this at? Right on the date line. Actually, it starts back in here, sort of falls to depth, has created a new consolidated pocket here, 5 degrees anomalies above normal, working towards the Galapagos. This is very good news. That means much more warming is in the pipe. It'll probably be 2 months before, if you drew a line from here and all this warm water before it works its way up into the Galapagos, it would probably be into, let's see, July, August, sometime in early August before all this is out of the pipe. And so what we need is more westerly anomalies in this area to push more warm water into this area, create yet another Kelvin wave. So you get a series of successive Kelvin waves just sort of blasting into the coast, and that is what makes a really good El Nino. A super El Nino, like the 97 El Nino, just had a perpetual pocket of warm water sitting here, non-stop westerly anomalies. It just kept feeding it, and the water just built up here, and then slowly worked its way all the way in through December, and then boom, we went into La Nina, cold water took over, and that was the end of it. But it's the warm water here that changes the upper level atmosphere, changes the jet stream, makes all the surf, and it takes the better part of a year after El Nino peaks out for the upper level winds to revert back to some other state. Once the momentum gets going, the atmosphere is a big ship. First off, it takes a lot of energy to get it to change its pattern, and that's what we're in the process of doing right now. Once it changes, it becomes very favorable for storm development, and even once you lose all the warm water, the ocean, it has momentum, the atmosphere keeps going, and it takes another year before it finally just settles down and then reverts to some other pattern. So right now, underwater, water temperature pattern looking very good. Here's another view of it, but this is older data. This is from June 2nd. We expect this to be updated any day, and probably we'll notice even here on June 2nd, warm water was sort of retreating. This goes further to the east, so this really goes up to the Ecuadorian coast. But we expect to see the Kelvin wave more isolated. Also notice this, little pockets of warm water up here, presumably falling down to depth, and also this pocket here, feeding the developing Kelvin wave. And yet one more view from NOAA. Now this is all the water in the upper 300 meters of the atmosphere, West Pacific here, East Pacific here. We're back in July last year. There was a big Kelvin wave here right about the same time as we are this year. Impacted the coast there. Upwelling phase of the Kelvin wave cycle, cooler water, and then 2 smaller Kelvin waves in the August time frame, and let's say October, November time frame. Not enough to really make use of the big Kelvin wave that hit. Things cooled down surface water-wise, and these two just didn't have enough. And yet another upwelling phase. Now here we are this year. Look at the size of this Kelvin wave and its life, and look at these temperatures here. This is 2.5 degree anomalies, which averaged over a large area of the ocean surfaces quite a bit of heat. But notice this here. Rather than cool water developing, look at this hook here. The new Kelvin wave forming per this was as of June 2nd, and warm anomalies building again. So this is very much favorable in support of El Nino development. And finally, the forecast from the CFS version 2 model, Nino 3.4 region. PDF corrected, more realistic. We were showing ones that had temperatures up darn near 3 degrees. That's not the case. This is rescaled, we'll say, to be realistic. Here we are in the June time frame. Temperatures per this chart about 1.2 degrees above normal, working their way up to by July 1st of July, about 1.35 degrees above normal, going to 1.5 in the September time frame, 1.7 degrees above normal in October, and then nearly 2 degrees above normal in the late November, December time frame. That, if it were to become true, would be very close to what one could consider a super El Nino. We don't know that we believe any of that, but it is a nice tease. Let's go take a quick look at what actual water temperatures are, though. In the Nino 1.2 region, they're right by the Galapagos. Here we go, May 23rd, temperatures 24th per this chart. Peaked out, they kind of dove off, now they're on the rebuild, and that's even before the new Kelvin wave is starting to impact the coast. This is a very good sign. And notice all this is well above normal and has been for since March, in the 18th or 19th or so. But the Nino 1.2 region is very noisy. It is very dependent on Kelvin waves coming in and the ebb and flow, sort of like the change in tide. Nino 3.4 is more steady state. This is the warm waters that are vecting to the west from the Nino 1.2 region. This is where most climate experts use to monitor the progress of El Nino. And notice this, we have a pretty much a steady state here, and now starting to work its way up. And this is exactly what we would expect as the first Kelvin wave starts working its way west into the Nino 3.4 region. And this says temperatures 1.3 degrees above normal. That's what the forecast was calling for. So we're actually doing pretty well. The expectation is these numbers will continue to creep up. So to wrap it up real quick, southern hemi swell working its way to California for early part of the week. Then things take a back seat. Maybe there is gale formation forecast under New Zealand. How strong it is and how long it will last and how well it aims to the north is yet to be determined. Watch the models. El Nino continues developing, looking much stronger than last year. First Kelvin wave, strong Kelvin wave, has erupted. Second one reorganizing off the coast of Ecuador, working its way in the next 2 months. Plenty of warm water on the way. The real key is we need no easterly anomalies. We need westerly anomalies, and we need to see that happen now in the next couple weeks would be best. The sooner the better, the more of it, the longer and the stronger they blow, the more warm water that comes to the east, and the stronger El Nino will become if it in fact does fully develop. But it sort of is looking that way. We'll know a lot more in the next 3 days whether those easterly anomalies disappear and we start seeing westerly anomalies reappear on the TAO buoy array. So for now, things are looking very good. Go get some surf. Keep your eyes on El Nino. We'll do this again next week. Same time, same channel. Thanks.